Hi, and welcome back to CIS 105. In this video, we're going to cover Chapter 1 of the Applied Business Computing Concepts ebook, which talks about information systems. One of the very first ideas I want you to think about is how everything changes in business, in your personal lives, in school. Every year, something is new, something is different. The first industry I want to take a look at really quick is the airline industry. In 1903, there was no airline industry. There were no airplanes. It wasn't until December 17th of 1903 when Orville and Wilbur Wright invented the very first airplane, which took its first flight and only lasted about a minute, that there was even the concept or reality of an airplane. That plane was called the Flyer 1, and it launched in Kitty Hawk, North Carolina. It was simply built from wood in a giant custom frame. A little bit after that, in 1914, St. Petersburg-Tampa Airboat Line became the very first scheduled passenger airline service. So up until that point, it was just trying to figure out how to get planes to be commercialized. So jump forward about 100 years, the commercial industry, airline industry now, is an industry that generates more than $200 billion in revenue each year. So if you think from 1903 to 2014, something that wasn't even in existence and now is prominent and something that people use on a daily basis and generates more than $200 billion in revenue each year, that's a pretty big feat if you think about it. The airline industry isn't the only industry that changes, where we're keeping in mind that concept of everything changes. Let's think back to 1953. That is the very first time when the double helix was discovered. It was discovered by three scientists, Watson, Crick, and Wilkins, and prior to that, we had no idea about DNA. We had no idea what our fundamental building blocks of life were made out of. So in 1970, scientists wanted to see what they could do with DNA. They already knew what it was, but how could they use that concept and that piece of information to change things? So in 1970, scientists invented new methods to swap out pieces of DNA so they could just change out a few pieces here and there. Jump forward a few years, well, 40 to be exact, scientist Craig Venter hid several coded messages in DNA and called his synthetic cell Cynthia. So we go from 1953, when we had no idea that the double helix existed, to swapping out pieces of DNA, to now using synthetic DNA to store information in coded messages. A few years later, a Cambridge geneticist, Ewan Burney, encoded DNA of all of Shakespeare's sonnets, a video of Martin Luther King's I Have a Dream speech, and a paper that he wrote, or a paper that Crick and Watson wrote in 1953. Encoded that on DNA. They sent it to a lab in Germany, where then it was decrypted, and they had an exact replication of that data. So they didn't lose any pieces, it was all there, they just had to retrieve that information and use it. So, thinking further down the road, what do you think? I mean, we're storing information on DNA, the building blocks of life. What is going to happen next in DNA? So like I said, keep in mind, everything changes, and it changes radically over the years. So now we know that two people experimenting with flight has changed over the years so radically that now it's an airline industry that is a multi-billion-dollar industry. We also know that a few scientists trying to figure out what DNA was has expanded to us being able to use DNA as storage media. Another way that things have changed over the years is space. I mean, prior to 1969, we had never sent anyone outside of our atmosphere where they could walk on the moon. So, in 1969, Armstrong and Aldrin walked on the moon for the very first time. A few years later, well, quite a few years later, in 2004, the very first private space plane was sent up into space. In 2012, there was an unmanned SpaceX Dragon ship that was sent into space to supply the International Space Station. Recently, though, in 2014, NASA signed a $6.8 billion contract with Boeing and SpaceX to launch astronauts back into space. So we're looking at going back into space more. So that's quite a bit of change. In 1969, nobody had been ever on the moon, to private planes going up, to unmanned planes going up, and now NASA is looking at going and trying to explore more in space. So what's the next big change that's going to happen? Well, who knows? I mean, there's so many things that could happen. We're not really sure of what the possibilities are. I mean, when the Wright brothers built the very first plane, they probably didn't expect it to grow as it did. So in space, we don't know. But let's just think. Who knows? Maybe in a few years we'll have an elevator that goes online and sends people to space in an elevator. I mean, it's a possibility. You never know. I mean, in 20, 40, 60 years, we could be having regular trips to the moon, to Mars. It doesn't matter. All that you need to think about is that everything changes. No matter what it is, there is always going to be change. Another item that has changed radically over the years, and that you're probably more familiar with, is Google Earth. I mean, in 2005, Google Earth was re-released by Google, obviously. But what is the next big step for them? I mean, right now it's static pictures of satellite images that look down, and I mean, there's not a whole lot you can do. But in, say, 20 years, maybe Google's going to release Google Live. So instead of looking at static pictures, maybe you're looking at video content, streaming live of wherever you want in the world. But things like that, those huge changes, really kind of bring up some ideas and that you need to pay attention to in technology and information systems. I mean, if Google ever went to a Google Live concept where you're viewing video in real time, what type of issues would Google face? I mean, if they implemented those live feeds, are there privacy issues? Are there regulatory issues? How could that technology be used? Could it be used for good? Completely. Could it be used for bad? Most definitely. I mean, do you really want the bad guys looking at live video streams of a bank or something to that extent? Probably not. But would you want the law enforcement to be watching houses for random activity that might not be good for that group of houses? Yeah, that could be a use for it. But see, there's always these pros and cons to how technology advances, how things change, how it's used. I mean, if you think about it, there's always pros and cons. So always keep that in mind. Everything changes. There's pros and cons to how things change. And keep that in the back of your mind whenever you're dealing with a situation like this. So I want you to think for just a little bit on what you see changing over the next 20 years in the technology realm. Computers, laptops, tablets, how are those going to be changed over the next 20 years? Your phones, how are those going to change? Anything relating to technology, just pause the video, take a few seconds, and just think of where you see the technology being in 20 years. To understand exactly how much can change in just about 20 years, let's take a look back at something that you all probably use on a daily basis. I mean, you have your cell phone that sits in your pocket, you can store music on it, thousands of songs, but prior to 1998, there were no portable digital audio machines, players. In 1998, though, the very first digital audio player was released. So prior to that, you had to use a cassette tape or a CD. You didn't have those digital files that you could easily just put on your device and listen to them whenever you want. In 1999, just to give you some statistics, in 1999, a simple MP3 player that could hold 10 songs cost about $450. I mean, if you think about that, that's how much your phone costs. But your phone holds thousands and thousands of songs, and it can also stream songs. I mean, it's probably not something that you would have wanted to deal with, but back then it was one of the best things out there at the time. So a year later, Samsung released its very first cell phone with MP3 capabilities. So we had cell phones, we hadn't merged them yet with digital media players. So like I said, in 2000, Samsung released their very first one. It was called the Uproar. A year after that, Apple jumped on the digital media player bandwagon, and they first released their first generation iPod. So in 2001, Apple released the very first generation iPod. 6 years later, it was their very first iPhone that Apple released with MP3 capabilities. So it hasn't been that long that Apple iPhones didn't have the ability to play MP3s. In 2014, though, like I said, smartphones hold now thousands of MP3s, digital pieces of content, and they can stream media over the internet connection that your phone has. I mean, look at that 20-year period. I mean, it's a little bit under 20 years, but if you think about that, we went from not having a product to do it to having it being commonplace, where now every device that you have pretty much plays digital media if you want it to. So now I've covered the airline industry, DNA, space, Google Live, MP3 players, and I've missed out on one huge technological advance in the past 50 years, the personal computer. And if I didn't cover that, I shouldn't be teaching CIS. So let's take a really quick jump back in time to 1975. In 1975, most people weren't really familiar with computers. There were mainframes and supercomputers that were owned by large corporations and governments, and these were computers that took up entire rooms and all probably cost nearly as much as the building itself. They didn't really have any home use. They actually had no home use at all, and they weren't really appealing or affordable to the average consumer. So in 1975, though, the very first personal computer was created. It was called the Altair 8800. It's the picture that you see in this slide right here. I mean, as you can see, there's switches, there's lights, there's not a whole lot to it. But this piece of machinery cost $395 to build it yourself, or $498 to actually have it come to you pre-assembled. Just to put that in perspective, those prices are about $2,000 in today's money. So would you buy something like this for $2,000? Probably not. However, back at that point in time, there were so many people that wanted their own computer for their own uses, just to even tinker around with it. So people flocked to these computers back in 1975. They could build them, they could play with them, they could figure out how they worked, and it was great. The Altair was super primitive. Like you can see, there's no keyboard, there's no monitor. It is really not computer friendly at all. You had to switch lights on and off to program it, but despite those limitations, people loved this machine. It was new, it was something they could use, it taught them to program, even despite it not being very user friendly at all. It was great for them. With the Altair, they could create their own programs, and just so you understand, in 1975, within 3 months, this machine, there was 4,000 orders placed for it. May not seem like a whole lot in today's world, but at the time, this is the very first thing that came out with a huge price tag. It did really well for itself. One thing just that you need to know about this computer is those switches turned electricity on and off. They are what is called binary. Zeros and ones, off and on, binary. It's a concept that you need to learn and understand. Around the time the Altair was released, two people that you probably have heard of before, Steve Wozniak and Steve Jobs, came together to create the Apple I. At the time, Steve Wozniak was an employee at Hewlett-Packard and was tinkering around with his own computer design. Jobs at the time was working for a computer game manufacturer called Atari and loved the prototypes that Wozniak was making. And he had a few suggestions. So the two came together in 1976 to build this Apple I computer. And they created it in Wozniak's garage, and they also formed the company, the Apple Company, in 1976. So some people might wonder, well, where did they come up with the name for Apple? Well, Jobs, when he was younger, worked for an apple orchard, and he thought the apples in the orchard were some of the perfect fruit, or the apple itself was the perfect fruit. So when they came up with the idea of the perfect company, the perfect machine, they decided on the name Apple. A year later, in 1977, they created the Apple II. The Apple II included a color monitor, it included sound, it included game pedals. However, this computer was priced around $1,300, almost about $4,000, well, almost about $5,000 in today's dollars. One of the biggest innovations in this computer, in the Apple II, was the operating was stored on what is called read-only memory. So instead of having to load disks into it and load the operating system onto the computer every time you run it, it was stored on a chip that when you turned on the computer, it would just launch the operating system. The friendly features of the Apple II operating system encouraged the less technically oriented computer fanatics to write their own programs. So the Apple II was a huge success and included a very simple spreadsheet program, a very simple word processing program, and some desktop publishing software. These programs gave the personal computer functions that went beyond gaming and actually made it something that the average person could begin to use in their home without having to worry about, well, this machine is only for corporate-y type stuff. So just remember, 76 and 77 was when Apple first created their very first computer and then their second edition of it. So around the same time that Apple was experiencing success in their Apple I and Apple II, a number of other competitors decided to join the market. So we went from these supercomputers and mainframe computers that took up an entire room down to devices that consumers could actually purchase if they had the funds. It was an opportunity to jump on a technology that was going someplace. So there was a few large competitors to Apple that jumped in the market. They were Commodore, Radio Shack, Osborne, and IBM. You've probably heard a few of these names over the years. The Commodore PET, though, was aimed at the business market. It did really well in Europe. The Radio Shack had its TRS-80, which was aimed at the US market. And just 1 month after its release in 1977, it sold about 10,000 units in the US. So Radio Shack did really well. The Osborne Company, though, introduced the very first portable computers. So think of this as the first edition of the laptop. The Osborne was released in 1981. Although it was portable, I mean, portable is, you have to think about it as, in the times, you had these big bulky computers. This was the very first one that you could kind of take away with you. I mean, it weighed 24.5 pounds. It had a super small little 5-inch screen, and it cost about $1,700 back in 1981, which is about $4,500 in today's money. I mean, 24 pounds, you're probably not lugging that all over the place. I mean, now we have laptops that are 2 pounds, but at the time, it was one of the best things that you could have. The Osborne itself was considered to be an overnight success. It sold 10,000 units in just 1 month. I mean, that's huge. And that was just 1 month of sales. I mean, it exploded after that. I mean, it was great. Despite the computer being super popular, the Osborne Company eventually closed. It was purchased by Compaq in 1983, and Compaq designed its own portable computer back in 1983. In today's world, I mean, you can see where it went from these portable computers, and companies have refined them over the years to make what you carry in your bags now. As I said earlier, IBM was one of the big competitors that jumped into the market with Apple. But in 1980, IBM really didn't see any value in personal computers. IBM was primarily making mainframe computers, so large corporations, governments used those big mainframes, supercomputers that were room-sized. They didn't really see the value in providing these personal computers to consumers. However, in 1981, IBM released its very first personal computer. It was called the IBM PC. So many companies were familiar with IBM mainframes, they automatically adopted the IBM PC, which made IBM really successful in the personal computer space. The term PC soon became the term used to describe all personal computers. So it wasn't just somebody that came up with personal computers and PC. IBM really kind of launched that idea, that name, out into the marketplace. IBM sold its PC simply through retail outlets such as Sears to reach the home users and quickly dominated the entire market. In January of 1983, Time magazine, playing on its annual Person of the Year idea, named the computer 1982 Machine of the Year. The IBM PC, like I said, it was business and consumer oriented. The features that it came with, it didn't have hard drive support, so you had to load everything by disk. So IBM, if you think about it, IBM was kind of set up to really do well because they already had the corporate customers. People who worked at those organizations knew of IBM, so once IBM finally jumped into the market and produced those personal machines, their market share of personal computers exploded. So now that we've covered the history of computers, we can look back at our original concept that I was originally discussing, that everything changes. So remember, we started out with huge mainframe computers that very few people used, progressed to clunkier personal computers that came out, to mobile computers, and now in 2014, computers are everywhere. I mean, literally, look around you and see how many computers there are. You may not actually think that there's a computer, but there's probably a computer in a lot of what you use. We have desktop computers, we have laptops, we have tablets, we have cell phones, we have TVs and DVR devices that use computers. Everything anymore uses computers. Even now, wearable technology uses some components of a computer in it. So your Fitbit, if you have one, or the Apple Watch that's coming out, all those use computers. And if we didn't have that progression over the years, we wouldn't be where we're at today. And then if we take a look in 20 years, where are we going to be with computers at that point in time? It's really interesting to think about how far we've come and how far we can go. But the whole idea behind this is keep in mind that technology changes. Everything changes in business, everything changes in technology, and it does so at a very rapid rate. So I've kind of ingrained in your mind by now that everything changes, and it's really important to understand that everything changes. But why is it really important to understand why technology changes? Well, in 1965, a man by the name of Gordon Moore, who was the co-founder of Intel, said that he predicted that computer processing power is going to double every 18 months or so, including the size of the internet. Imagine a car maker saying that they were going to double their gas mileage every 18 months. It's kind of something that no one would believe. And at the time, no one really believed that Moore was right. However, right now we have this idea or this concept which we call Moore's Law. And it holds true with very few exceptions and some changes over the time. But if you look at the graph on the screen, you can see that computer processing power, or the transistors that show up on a computer chip, have doubled roughly every 18 months ever since he made that hypothesis. This is important because the more transistors that we can pack on chips, the more processing power that we can have, the smaller it can be, and the better the devices that we have. So that's why it's really important to understand that everything changes and technology changes at an exponential rate. It doubles pretty much without going over it about every 18 months or so. It's kind of slowing down right now, but it's held true ever since he made that back in 1965. So you might be wondering now, okay, so this guy, Gordon Moore, created this prediction that computing power was going to double every 18 months or so. Why is that important to you? Why is it important to business computing? Well, in 1988, let's just think back to 1988. One PC, one computer, cost about $14,000 back in 1988, a really good one. With how technology has progressed over the years, in 2014, you could buy about 40 PCs for that same price tag. So 40 PCs cost about $14,000. I mean, and that is all because of how technology has changed over that span of time. The amount of transistors, the amount of computing processing power has doubled over and over and over again, making it where it's so cost friendly to build computers that now you can buy so many computers at a fraction of the price. Alright, so you now probably kind of understand that technology changes, the processing power, the more you can get out of it, the cheaper it goes, the more you can provide. That's all well and good. But why does this make sense to business computing? Well, let's just have you pause the video for a second. Think that you're going to buy, or think through this idea that you're going to buy 1,250 smartphones. What smartphone platform would you buy? Would you care? Would you research? Would you buy Apple, Android, BlackBerry, Windows? What operating system would you purchase on those? And think about why you would purchase it. Hopefully you paused the video for a few seconds and thought about the question. But for this example, if you chose Apple, Android, or BlackBerry, you chose incorrectly, and now your competitors have what is called the competitive advantage. I'm not saying that Windows is better or any of these devices are better, but my point is that when you're working in an organization, you need to make sure that you're always taking advantage of what's coming next and taking a look at what's out there and how it can benefit your company. Sometimes you may be risk adverse and say, no, we're going to hold off, it's not going to hurt us in the long run. But sometimes you need to make decisions of, well, we need to jump on this personal computer because it's going to be the next best thing and it will provide us a competitive advantage. When you get something wrong in business, your competitor likely got it right. So that's why it's highly important to businesses to always be thinking a few steps ahead and jumping on things that right at that moment may not be what they think is going to be the next best thing, but they need to try to predict that it may provide them some future benefit and some competitive advantage in the future. So when organizations make these technology-based decisions, they can either be a leader or a follower. This is really based on the organization's risk tolerance. And risk tolerance is how much risk are they willing to assume for a potential outcome. They don't know what the outcome is going to be. It also is based on whether or not that decision is going to provide them a competitive advantage or not. So leaders buy the newest technology and they may or may not get the competitive advantage. And followers wait to see what works for their competitors and then they jump on if it actually works for the competitors. But being a follower, they lose the competitive advantage. So what is better, a leader or a follower? It really depends on your organization. It depends on what your risk tolerance is, what the competition is like. There's a whole lot of factors. And so when you're in an organization and you're trying to make these decisions, you really need to assess your organization's culture, your organization's risk tolerance, and the competition to make the best decision for your organization. Now that we understand how technology changes, how organizations make decisions about technology, What is this business information technology that we always hear about? Well, business information technology is the study, design, implementation, support, and management of computer-based information systems, particularly software and hardware. There are several important aspects in business information systems. The very first one is people. If you think about it, computers are dumb. They can't work without interaction from a person. Users need to operate the programs, or even users need to develop programs, and then they can set them to automatically run. So information systems need input from a user at some point in time to actually run. So that makes people a very important aspect in business information systems. The next important aspect of business information systems is competency. Gaining computer competency in business is paramount to success. If users don't have computer competency, they're going to struggle. I mean, computers are everywhere in business anymore. You need to have some low-level foundational knowledge of how computers work to actually succeed in business. In this class, gaining competency in Excel and Access will allow you to take advantage of these programs in your future college career, in your professional lives, in your personal lives. So it's a really important concept in business information systems. The next important aspect in business information systems is attitude. Attitude plays a vital role in gaining computer competency. Again, computers are not magic. They are completely dumb. Without interaction from you, they're not going to do anything. So with a little bit of knowledge, you can make amazing things happen with a computer. You're really limited only by your imagination. So don't be afraid to try something that hasn't been done before, or if you think it may or may not work, go ahead and explore those new concepts, those new ideas. Be okay to fail, because the failures or your perceived failures are going to get you one step closer to success in using a computing system. The next important aspect of business information systems is critical thinking. Learning computers can seem extremely complicated and overwhelming. I understand. I was there years and years ago. So if you're at that point, just remember this simple acronym, KISS. Keep it simple, stupid. Oftentimes, end users overthink things. Computers are extremely simple. You provide input, they provide output. Take a step back if you ever run into an issue. Analyze the problem. Identify the solutions that you could possibly go after, and then implement those solutions. When you've solved a problem, so if you're working in Excel and you run into an issue, take a step back, analyze what's happening, and work through it logically. When you've solved the problem, take a few moments, look at what you have learned, and commit it to memory so that in the future when you run into a similar situation, you can draw on that knowledge and grow yourself. Critically thinking about problems will allow you to always gain an advantage. So build upon your personal knowledge, think things through, and critically understand what the issue is and how you're going to solve it. The last important aspect of business information systems that I'm going to cover is best practices. Best practices are a management process, technique, or method that is the most effective way of doing something. So one example I want to give you is the Project Management Institute creates a collection of project management best practices in a book. It's called the PMBOK, which is the Project Management Body of Knowledge. So in the project management field, there's a book that provides you best practices that you can implement on your projects. You don't necessarily have to use them, but a large group of individuals that took a look at the most effective ways of doing things put it into a book, and it's always evolving. So that's one example of best practices. When implemented, best practices make the business become more efficient, you waste less resources, and you provide better products and services. So let's have you pause the video a moment and think, if you improved your best practices or you implemented best practices in your organization and you no longer need a group of employees, what should you do? Now that you've thought on this question just for a few moments, The answer to this, unfortunately, is that you have to fire, or you should fire, those employees if they are no longer needed because best practices have made your organization more efficient. You need to remove that so you don't waste resources. Over the next few slides, what we're going to do is some high-level understanding of what the rest of the course is about. So computer hardware is the tangible and physical aspects of computer hardware. This includes mainframes, which are huge room-sized computers, mid-range, which are smaller server-type computers, and microcomputers, which is what we're going to talk mostly about in this class, and that includes laptops, desktops, handhelds, tablets, things to that extent. In order for business computing machines to actually work, it requires what's called system software. Among other things, system software makes the hardware of the machine actually work. It's a collection of small computer programs that accomplish a specific task. The BIOS is one of the most important pieces of system software there is. BIOS means Basic Input and Output System. This is a software system that starts the computer. It connects the data between the operating system and the hardware. Another system software is called the boot program. This is what loads the operating system from the ROM, the random or read-only memory, into the random access memory, the RAM. Another piece of system software is the device drivers. Device drivers are little pieces of software that connect, say, your printer to the computer and allow you to actually use it. So device drivers are specific to a device that is attached to the computer. So once the system starts up, the operating system takes over, and these are what are also called platforms. Operating systems are a collection of computer programs that work together to manage the hardware and software to make sure the computer is actually working correctly. So operating systems take on file management, so when you create folders and add files to those folders, it keeps track of where that's located. Multitasking, so if you think you're on your computer and you're on Blackboard and you're on Microsoft Excel working at the same time, your computer operating system is making sure both of those run seamlessly. Memory management, so when you launch a program, the operating system dedicates a little bit of memory so it can launch that program, and then it dedicates some more memory if it actually needs it. So it kind of moves memory around so that every program gets what it needs. Disk management makes sure that your computer hard drives actually function correctly. Just a really quick background on some operating system history. So Bill Gates and Paul Allen used what was called a programming code which was called BASIC, the Beginner's All-Purpose Symbolic Instruction Code, to write the very first program that led into Windows. This programming language called BASIC transformed an industry because students could easily learn it. It was very easy for them to sit down, understand how to use BASIC, and create their own programs. IBM approached Gates to write an operating system for the IBM PC. Remember back into the history, IBM created the very first IBM PC. They approached Bill Gates to write an operating system, which eventually developed into what is called MS-DOS. In 1972, users interacted with what was called a command line. Xerox decided that they needed to design something that was a little bit more customer-friendly and user-friendly. So they designed Alto, which was a computer with the very first graphical user interface, or what's called a GUI. Since Gates and Allen created the very first operating system till today, we now have a bunch of different operating systems that are out there. We have Microsoft Windows, we have the Mac OS, we have Linux, and we have Unix. Linux is a free open source operating system that you can use if you want to go on and download it and use it on your computer. So we understand that the computer starts up, it loads system software, which loads the operating system, which controls everything on the computer. And now we have what's called application software. Application software performs specific tasks like creating budgets, resumes, professional presentations. These pieces of software are created specifically for doing a job that a user wants to do. Chances of an application software not meeting the end user's needs are completely remote. So if you launch PowerPoint, That piece of software is built specifically to do one task, creating PowerPoint slides. Application software, unlike operating systems, must be turned on by the user. So if you think of this, Microsoft Excel is not going to launch by itself. You actually have to wait for the computer to turn on, then you go to Start, and then you click on a folder, and then you open up that program and launch that application software. Some common application software that you probably know is email application software such as Outlook, word processing, spreadsheets, database software, presentation software, project management software, and photo and video editing software such as Photoshop. Business computing software is really concerned with 4 basic types of applications: spreadsheets, word processors, database software, and presentation software. Typically, these business computing application programs are put together in a package, which is called a productivity suite. Productivity suites are collections of business computer application programs that have associated functionality and share typically the same type of graphical user interface, or GUI. If you think of the Microsoft Office 2013 suite, if you open up Word and then you open up Excel, the layout of the application is pretty similar. It has different functionality, but you can easily go from one software application to another. Productivity suites are also called software suites or application suites. So those are 2 terms that will be interchanged with productivity suites fairly often. Productivity suites also allow really smooth data exchange. So if you want data from an Excel spreadsheet into a Word document, you can easily get that information over into that Word document without much trouble. One of the most important and popular productivity suites out on the market today is Microsoft Office. Pretty much every business, every individual has used or does use Microsoft Office on a daily basis. So when you're learning application software, what is the most important aspect of learning that application software? In this class, I'm going to tell you it's attitude. Attitude is paramount to learning any piece of application software. Sometimes it's not easy learning a piece of application software. However, if you go into it knowing that you're going to stumble a few times, but you're going to learn some new concepts, you're going to learn some new ways of doing things, and you have a good overall positive attitude, you're going to be able to take away from learning that software a whole lot more than if you go into that and say, I hate this, I don't want to learn this piece of software, I don't have any use for it. If you have a bad attitude, you're not going to get anything out of it. The reason why I mention this is we're going to be learning Excel and Access in this course, and it is really important for you to understand that these 2 pieces of software are going to help you throughout your professional and the rest of your college life. If you go into it with a negative attitude, you're not going to learn what you need to learn, and it's going to be a miserable experience for you. So just remember, it's going to be tough at times, but you're going to learn something that you'll be able to use the rest of your life. So keep a positive attitude the entire time throughout this course, or any time that you're actually learning a new piece of application software. As I said in the previous slide, application software allows for data be exchanged between applications fairly seamlessly. One of the ways that data can be shared between software suites is cut and paste. Cut and paste is static. So if you think you cut a piece of information out of Excel and you paste it into Word, it's static. That data doesn't change. You're just copying and pasting from one location to the next. To make it a little bit more dynamic, there's OLE, which is Object Linking and Embedding. Object linking takes a look at one program and it says, okay, I know that this chart is found in this Excel document. The user wants me to post that same chart into Word. I'm going to link it, which makes it dynamic. So if you change the content in Excel, that content is going to change in Word also. You can also embed objects from another piece of software. So if you copy a chart from Excel and you embed it into Word, that chart's going to look the same, but when you change the data in Excel, it's not going to change in Word. So that's the difference between linking and embedding, and cut and paste. So cut and paste is static. Linking is dynamic, so if you change something, it changes. And embedding is also static, so if you change something, it doesn't change when you embed. So that's chapter 1. If you haven't read the chapter yet, go ahead and read it now so that you have all the concepts that we discussed in your mind fresh, so that when you go through the chapter, you actually have some idea of what the chapter is talking about. If you have any questions, let me know. If not, I'll see you in chapter 2.